Let's start with paper 9, question number 1. Question number 1 says, if Q and 3Q are the charges enclosed by two concentric spheres as shown in the figure, the electric flux through the sphere S1 must be. Now we know from Gauss's law, flux phi will be equals to total charge Q in. Q in means the total charge enclosed by the whole Gaussian surface upon epsilon naught, right? So what is the charge enclosed by the first sphere S1? Be careful, this S2 is already inside S1. So the total charge, this Q and this Q, both you will have to count when you are dealing with charge S1. So the total charge enclosed by S1 will be, so flux by S1 will be 3Q plus Q whole divided by epsilon naught. Okay, so this will be 4Q by epsilon naught. Correct answer is option A. Okay, be very careful when if there is one more sphere, you will include that too. Okay, but if you are dealing only with S2, then only Q. So let's move to question number 2 here. Question 2 says, if Q and 3Q are the charges enclosed by the two concentric spheres as shown in the figure, the flux through surface or sphere S2. Now I have already explained in the previous one, again I am repeating. If you are looking at S2, only the charge Q is enclosed by S2. So flux phi according to Gauss's law will be charge Q by epsilon naught, right? Okay, so flux, this is because of S2. So let me write here S2, that will be Q by epsilon naught. Okay, so correct answer is option B. Let's move to question number 3. If Q and 3Q are the charges, okay great, are enclosed by the two concentric spheres as shown in the figure, the ratio of the flux through the sphere S1 and S2. So let me repeat again, phi S1 will be the total charge, which is 3Q plus Q whole divided by epsilon naught according to Gauss's law, which will give you 4Q by epsilon naught. And phi S2 will be equals to how much? Phi S2 is Q by epsilon naught, right? Now they are saying what is the ratio of the flux from S1 is to S2. So if I divide phi S1 upon phi S2, it will give me what? 4:1, correct? So correct answer is option A, 4:1. Let's move to question number 4. It says, if minus 2Q and 3Q are the charges enclosed by the two concentric spheres, the electric flux through the sphere S1. So you can see here, flux phi S1 will be equals to the charge 3Q minus 2Q. Sir, we have to take the negative sign? Yes, because flux is a scalar quantity. So 3Q minus 2Q upon epsilon naught. So that will be the total charge enclosed. So this will be Q by epsilon naught. Be very careful. The correct answer is option B. This was 4th question. Let's move to 5th one. It says, if minus 2Q and 3Q are this, then what is the flux through the sphere S2? As usual, S2 will have flux phi S2 will be equals to, what is the charge enclosed by S2? Minus 2Q. So correct answer here is option A, minus 2Q by epsilon naught. Let's move to question number 6. It says, the electric field E, which is given by 3 into 10 to the power 3 I cap means along x-axis. The electric flux of the field through a square of area A is given here 10 centimeter square. So centimeter square converted into meter square will be 10 to the power minus 2 meter square when its plane is parallel to YZ. Okay, so plane of the area is parallel to YZ, which means the normal to the area will be along which direction? If something is parallel to YZ, its perpendicular direction is which one? X-axis. So this will be I cap here. So let me write here I cap. Okay, so let's multiply them to get our flux. So flux phi will be equals to E into area, right? So this will be 3 times 30 into 10 to the power minus 3 and minus 2. This will be 1. So this will be 300. Okay, 10 to the power, oh, I did a small mistake. Centimeter square, when you are converting into meter square, it will be 10 to the power minus 4, right? So this will be minus 1. Let me repeat again. You have 10 centimeter square. When you convert it into meter square, it will be 10 into 10 to the power minus 4, right? So minus 4, and this will give you 10 to the power minus 1. So this will be 3. Okay. Okay, electric field is 3 into 3 Newton meter square per coulomb. Okay. So electric field is 3 into 10 to the power 3, and that is area is 10 into 10 to the power minus 4. Yeah. So 30 into 10 to the power minus 1. Correct. So that becomes 3. So correct answer here is option D, none. Question number 6. Let's move to question number 7. A charge Q. So here it is written, this is our charge Q. Okay. So let me just make it with a different color so that you can see it properly. This is small q, is situated at the center of a hemispherical surface. As shown in the figure, the electric flux through the given hemispherical surface will be how much? So if it is a hemisphere, okay, you can imagine that this was a part of a huge sphere. So if you imagine a Gaussian surface like a sphere around this, okay, the total flux through this whole sphere must be, so let's imagine this as a sphere here, okay. So what will be the flux through this whole sphere? It will be q by epsilon naught through whole sphere. So how much, if field lines are going here in all possible direction, the amount of field lines going up will be equals to the amount of field lines going down. So how many will be there from the down part? They will be half of this, correct? So the flux through hemisphere will be q by 2 epsilon naught, correct? So option B is correct for the 7th one. Let's see the 8th one. If a charge q is placed at the center of a cube, the total flux coming out of the cube. So if this is a cube and you are placing a charge at the center, then what will be the flux? According to Gauss's law, flux phi will be q by epsilon naught. Okay, field lines will come out from all the surfaces in all possible 3 dimensions. Option B is correct. Let's move to question number 9. If a charge q is placed at the center of the cube, the flux coming out of each face. Now be very careful in this case. The total flux which is coming out of this cube is how much? Just now we found q by epsilon naught. This is total. But through each face, how many faces are there? 1, 2, 3, 4, 5, 6. So flux phi will be 1/6 of q by epsilon naught. So correct answer is 1/6 of q by epsilon naught, option A. Let's move to question number 10. Gauss's law is applicable to open surfaces only, closed surfaces only. Okay, so that's the correct answer. Okay, this was paper 10.